In this example, we're going to graphically solve an equation and also an inequality, and we're going to do so using technology. So the first task we have is to solve the equation 2x cubed minus 5x plus 1 equal to negative 1/2 x plus 1. Okay, so I'm going to go to Desmos, and I'm going to enter the equation given. So we have 2x cubed minus 5x plus 1. Okay, so that's one side of the equality, right? And I want to graph the other side of the equality because we want to find out where they're equal. Okay, so we have 1/2 x plus 1. Okay, so the other side of that equal side is a line. Okay, so where are the intersection values there? Because we're trying to solve an equality. So they're right here. I'm going to highlight those intersections because those are the main things that we need. So now that we've graphed this, we've graphed both sides, right? So this side, the cubic, 2x cubed minus 5x plus 1, that is in green, right? The orange graph is the negative 1/2 x plus 1, right? And so the goal here when we're trying to find an equality, we're trying to find the values of x that make that statement true, which means where are the x values where both of those functions carry the same y value, and it happens in 3 places, right? I highlighted those intersections. So it happens at x equal to negative 1.5, x equal to 0, and x equal to 1.5, right? All 3 of those values. And so the solution set is negative 1.5, 0, and 1.5. All right, let's take a look at this inequality. Okay, so with the inequality, same story. We're going to graph both sides of the inequality. So we'll have negative 0.05 x squared minus 2.5x minus 20.1. And then the other side of the inequality is 0.05 x squared plus 1.9x plus 19.2. Okay, so in this window, we're not seeing a whole lot, right? We're wanting to know where the first one that we entered is below the second one. And it actually might help if we define these. Maybe we could call them f of x and g of x, for instance. And then that might help us with the inequality later. Okay, so and you notice it'll graph it whether you define it as a function or not, which is kind of nice. You can use the zooming features or you can just zoom out a little bit. Okay, so we've got 2 parabolas, right? In fact, if we zoom out another little bit, we've got it, right? So here's our graph, and we've got these 2 defined here. And we want to know where the first one is below the second one, right? So the purple one is the first one, right? And we want to know where f of x is below g of x. That was the question. Okay, so the purple graph, where is the purple graph below the green graph, right? That's really what we're being asked here. And I want to get the intersections there because that's really important in terms of how we define this. Okay, so as we're trying to define the solution set to this, let's make sure we know what we graphed here. So the purple one on the graphing set is this first, the left-hand side of the inequality, and the other one was sort of in a greenish color, right? So this is the green graph, and our question is where is the purple graph below the green graph, right? So the part that's shaded there is the part where the purple graph is below or is less than, has y values less than the green graph, okay? So the solution set, the values of x that make that true, I'm going to essentially write the domain of that shaded part. So negative infinity up to, what's the x value at that first intersection? Negative 31.539, right? And it's strictly less than, so we're going to use an open bracket. In union with, what's the other intersection? The x value, negative 12.461 out to positive infinity, okay? All right, so the shading just keeps going and going and going there. So, okay, so hopefully that makes sense. Whether you're talking about an equality or an inequality, when we're solving it graphically, we really depend on those points of intersection of the graph, right? So with an equality, we're looking at the x values of those intersections as being the solutions, right? And when we're looking at an inequality, those x values will often be the endpoints of whatever intervals that you have that satisfy the inequality.